Good morning to all. I'm Nivita. Now we are going to see the first unit 8-bit and 16-bit microprocessors. In this unit, we will study about 8085 microprocessor architecture and then instruction set of 8085, addressing modes of 8085 and some assembly language program using 8085 architecture. And then 8086 microprocessor architecture. This is a 16-bit microprocessor architecture, and we will see instruction set, addressing mode and assembly language programming of 8086 microprocessor. The basic of 8085 microprocessor architecture is an 8-bit processor. We are using a 40-pin integrated circuit, and then we are using the plus 5 volt power supply. It's run at a maximum frequency of 3 MHz, and the maximum address bus width is a 16-bit. So we have calculated the 2 power 16, that means zeros and 1 combination of 16 is equal to 64 KB of memory. This is the architecture diagram of 8085, which has the first serial IO, and then serial IO control, and then serial output, and then serial input data, and then serial output data. We are include the data in a bit by bit manner. We are using the serial IO control. Next, we are having the accumulator. Accumulator will give the first data to the arithmetic and logic unit, and as well as it will store the result of the final data. Arithmetic and logic unit, which is used to perform the arithmetic as well as logical operation, basics of addition, subtraction, multiplication, and gate, OR gate, NOT gate operations. We are using 3 temporary register in this architecture, that is temp register, here W register, and then eject register. In 3 registers are only used by the processor. User, we cannot access these registers. And then register select, we are having the 6 register. In this 6 register, we can access those 6 register. First one is a B register, C register, D, E and H, and then L register. If we are using a 8-bit register, means we are choose the B register as a separate, C register as a separate, those 4 register as well as using as a separate register. Otherwise, the 8085 processor will act as a 16-bit register. If you are combining a B and C register as a 16-bit register, or parallel DE register is a 16 register, or HL pair is a 16-bit register. And then we are using a stack pointer is a 16-bit, and then program counter is a 16-bit. We are using a address buffer as a 8, and then data address buffer is a 8. We are using lower base AD0 to AD7, and then a higher address A8 to A15, and here AD0 and AD7. That means data and address lines are multiplexed. We are using address latch enable. We can demultiplex the address and data lines. That means if you are giving a address signal as a 1, means that will act as a address line. If you are giving as a input 0 means it will act as a data lines. After that, we are multiplexing, that will move to the instruction register, and then instruction register that will move to the instruction decoder, and then machine encoding. All the signals are connected to the timing and control. We are using the x1 x2 as a clock generator. Between the x1 and x2, we are using the crystal oscillator for generating the clock signals, and then clock out is equal to reset the clock generator, and ready signal is connected to the timing and control signals, because processor and peripheral devices are working in a different speed. If we are using these ready handshake signals, we are synchronize the processor and peripheral devices, and then control signals are used. Read bar is equal to read that means fetch the signal into the processor. Write bar is equal to transfer the data into the memory, and then ALE is address latch enable. The combination of S0, S1, IO bar memory is used to fetch the read and write of IO, and then memory read, memory write operations will be performed. And the direct memory access, we are using 2 pins hold and HLDA. And then reset in, reset pin are used to reset the processor and then reset the processor out. We are using one power supply that is a plus 5 volt, and you are using the ground signal. So let's we'll send the results to the processor, that means internal bus. Yeah, we are using a flag flip-flops. These flags are used to provide the status of the arithmetic and logic unit. And then interrupt signals are used. In that interrupt signal, INT RS 5.5, RS 6.5, RS 7.5. Trap is the highest priority compared to INTR. This INTA bar is interrupt acknowledgement signal. One bus cycle is, if you are covering one 8-bit signal is an input and provide the one 8-bit output signal.